Labguy here. This is a quick update video on the state of my mechanical television work. I have been off and on working on a three-phase motor driver to make it possible to build mechanical televisions using disk drive motors, and I have yet to make the damn thing spin. I can make it buzz, but I can't get it to spin. I have been studying BLDC motors, brushless DC motors, intensely, and all of the information that claims to have very simple solutions to making them work is a lie. There's nothing simple about driving them at all. My approach was to drive them with a simple three-phase 120-degree pseudo sine wave or even a square wave. This apparently doesn't work, but I have a few more waveforms to try, and each time that I undertake the circuit, since I'm doing this all in hardware, it involves quite a bit of rewiring each time. So it takes time. One of the principles of my project is no software, period. No microcontrollers, no software. Well, if you look up BLDC motor drivers, they're all computer based. As far as I'm concerned, any kind of video system that attempts to synchronize with the use of a microprocessor is dead wrong. What people don't understand is due to internal housekeeping tasks inside of a microprocessor, you cannot guarantee absolute timing. So some of the output pulses will jitter in time because the processor will be interrupted internally to do an internal service request and then come back, and lo and behold, one of the critical video timing functions has timed out and is processed late. It may only be 250 nanoseconds or 100 nanoseconds, even 50 nanoseconds. It's not acceptable. So I always use hardware-based solutions, dedicated hardware, digital logic, analog circuits, so that we don't have any unpredictable timing. In television, unpredictability is not acceptable. Also, the circuits I'm trying to design must be absolutely simple so that a beginning electronics enthusiast, television enthusiast, can copy my circuits, and if they wire them correctly, they turn them on and they work. I don't want to dump you into a black hole of troubleshooting and scratching your head or coming to the conclusion that my circuits don't work. I will not publish them if they don't work. My goal is to make projects that the average person can build, that will work immediately and will bring you a sense of joy at accomplishing something that appears on the surface to be hideously complex, but between you and me, it's really simple. So let me show you real quick the breadboard for the three-phase motor driver. Here we go. This is the breadboard I use for testing my three-phase motor drive. Down here is the clock oscillator and the sequencer. Optical isolators to isolate the output power transistors, which ultimately connect over here to the three-phase motor, which is off board. I watched a video yesterday where the fellow showed the timing diagrams for how to do it wrong, and they're very close to the timing diagrams I was using, and so I'm going to try that one last time. I have almost given up on this approach. but if I can make it work, then we will have a system that allows you to use a disk drive 3-phase motor with a printed paper disc, which is very light and easy to spin. And the advantage of this type of drive is that when you turn on your mechanical television, the disc will immediately be spinning at exactly the right speed, and we only have to bring it into phase. Now, for a lot of you out there who've worked with DC motor mechanical televisions and have successfully finally made them work, you know that getting your disc servo to lock is one issue. That's the speed servo. The second issue is bringing it into phase. That is, that the picture, the scanning of the picture frame-wise is at the right time, so that you don't have your picture split down the middle, since you use vertical lines. You don't end up with a picture split down the middle of frame N and frame N plus 1. So that is my goal, is to achieve these results. Again, circuitry needs to be simple. Now you might say, well, gee, Labguy, that doesn't look that simple. Well, there's no microcontroller, so there's no programming. The chips I've used are the 555 timer and some simple 74HC family logic chips. There's a counter and a 3-line to 8-line decoder, some NAND gates and NOR gates, and a couple of flip-flops. Let me insert a couple of clips of me working yesterday on the mechanical televisor, and you can see what I accomplished there. And primarily it was to fix the tack pickup for the servo holes around the rim of the disc. Let's zoom in on our disc. You can begin to see the Nipkow scanning holes, and on the outer rim of the disc are the tachometer holes. Well, I was using a standard optical interrupter, which had several disadvantages. This couldn't see the holes on the rim of the disc when it was spinning. It would work if you turned it real slow, but it didn't work. So I constructed my own isolator and used an extremely high intensity LED and a phototransistor, and it's now bulletproof. It works very well. You will also see in the video clips, these will be random video clips from yesterday. You will see that in operation, and you'll see that I took my 4-channel oscilloscope and connected it to my professional Sony LCD HD monitor by VGA cable, and solved the issue with the wacky monitor in the scope. We now have a nice viewable scope display, and it also gives me elbow room to work with the actual scope and the camera over here filming the Sony display. So these are all win-wins for Labguy's world here. So without further ado, let's look at a couple of video clips from yesterday. There's the new photo sensor. Okay. So it's working. And let's see, does it work over speed? It does. So let's figure out. Okay, that's supposed to be 400 hertz, 2.5 milliseconds. Okay. One millisecond per division. Okay, and we want to dial it to 2.5. Okay, looking up here, it says 2.5 milliseconds per division. I don't know if you can see it. But anyways, so let's set the speed to give us 2.5 milliseconds. Of course it's unstable at speed, but that's 12.5 revolutions per second. There we go. It's right on speed right there. Maybe wobbling, but it is picking up the pulses, and it's running right at speed. That's where the picture would be. Alright, I'm going to take a break now, because you can imagine this thing is irritating to work on. So that completes the summary of the mechanical television progress in the last 2 or 3 days here. I hope you enjoyed looking at the schematics, at some of the trials and tribulations that I've edited in there. I don't even know what they are at this point. I'm shooting the outro in advance of the editing, so you get what you got. So if you have any questions, leave them in the comments. Thank you for watching, and greetings to all the new subscribers. Welcome. Welcome to my channel. I hope you enjoy what you see. If you know somebody, especially young people, who could use a hobby or have interest in television related subjects in terms of technology, be sure to send them to the channel and have a look. If you like the channel, be sure to subscribe. Thumbs ups are always appreciated, but in general you won't hear me asking for those anymore in my videos. So the only reason I mention it now was to tell you that I won't be mentioning it anymore. So have a great day, and until next time, Labguy out.